All right, let's do this last section for chapter 7, 7.8. More graphing. Yay, I know. Today is about phase shifts, which is basically just a horizontal shift to the left or to the right of a trig function. It is a transformation. A phase shift is a horizontal transformation to the left or right. We just make it fancier. Phase shift for trigonometric functions. Okay, so it says, graph a sinusoidal function of the form y equals sine of omega x minus phi. That little symbol there is pronounced phi. And then, of course, the fancy W is omega, and that letter is B. Okay, sorry. Okay, so I'm going to show you do it by transformations. I'm going to show you how to do it by key points, and then you decide what you like the best. Okay, so first thing we start with is transformations. Y equals 3 sine of 2x minus pi. It says find amplitude, find the period, and the phase shift of the sinusoidal function. Okay, so doing this by transformations, the first thing I want to do is rewrite it so you can see all the transformations that are happening, okay? So when I say rewrite, all we're gonna do here is that on the inside of this sine function, and everything's gonna happen on the inside, what I'm gonna do is factor this 2 from everything inside. And you're like, well, how can you factor the 2 if the pi doesn't have a 2 on it? Well, just remember that everything is factorable. We can manipulate it in such a way to where you'll see that this actually makes sense. So when we rewrite this, I'm going to say 3 sine and of, I'll put a bracket here just to be neat. So I'm factoring that 2 out. And then in parentheses, you'll have 2. Once you factor the 2 out, you're going to get 2 times x minus pi over 2, close parentheses. That's it. I factored the 2 out. If you want to check your factoring to make sure it's correct, just distribute it back in. And if you do, you're going to get the original function back. This is the original function. All we did was factor a 2 out of the inside. But remember, all of this is still happening on the inside of the sine function, in the argument of the sine function. Okay, which means now, since I rewrote it, you can actually see what type of transformations are happening here. Okay, so if I zoom in, the first transformation is a vertical stretch. By 3 units. The next transformation that's happening is a horizontal compression by, remember, always think opposite. This is going to be by 1/2. And the third transformation I guess the arrow should be pointing the other way. There we go. Is going to be our horizontal shift to the right. This is a horizontal shift right by pi over 2. This inside is also considered the phase shift. Okay. And I have the parent function coordinates that we want to transform. And I already applied these to, the type of transformations we are going to apply to the parent function coordinates. Okay. So right here on the left side, you see these are the parent function coordinates for sine. And once we transform, if we are going to transform the x values, remember that any type of horizontal transformation affects the x values. So the first type of transformation we have is the horizontal compression by 1/2. That's what I have right here. You're going to take 1/2 and multiply it by all the x values. And then the next transformation you have is after you compress it by 1/2, you are going to add pi/2 to that transformation. So this means after we compress it, we shift it to the right pi/2 units. And that's what I have represented here. Okay. So this means let's go ahead and take all of these x values and multiply them by 1/2 and add pi/2. Ooh, lots of fraction work unless you have a calculator handy. Let's try this out. Let's see, can I fit it all here? I think so. Handwriting might be a little ugly. Okay, let me find the right calculator that I want. I'll choose this TI-30. And for the first one, we're going to have 1/2 times the x value of negative pi/2 plus pi/2. And look at that. We're going to get pi/4. All right. It's negative pi/4 plus pi/2. So we get pi/4. And then we'll do it for 0. I don't need to type it in the calculator for 0. 1/2 times 0 is 0 plus pi/2. You'll get pi/2. And then you can try it again. I'll just rewrite this statement. And now it's 1/2 times positive pi/2 plus pi/2. And we'll get 3 pi/4. And then, so that goes there, that goes there. And then you'll do it for pi. So it's again, I can rewrite this statement. And I'm just going to put a pi here. So let's go ahead. I'll just make that pi/1 because that's the same as pi. And we're going to end up with still pi. Crazy, because that'll give you pi/2 plus pi/2, which gives you 2 pi/2, which is still pi. And then we'll do it for 3 pi/2. Type the same thing. Make that a 2. Make that a 3 pi. There we go. Hit enter, and you'll get a 5 pi/4. And last, we'll do 2 pi. Same exact statement. Make that a 1. And make that a 2 pi. And we'll get 3 pi/2. Okay. So we have just transformed all the x values. We have compressed them and then shifted them to the right pi/2 units. Okay, and now here comes the easy part. Take all of these y values and just multiply them by 3. Oh, that's so simple. So -3, 0, 3, 0, -3, and 0. And we can, of course, check our work. I can check one of these values. Let's say I want to check pi over 4 and -3. So I'll plug it into my calculator. I'll say, make sure it's in radians. And I'll say 3 sine of 2 times pi over 4 minus pi over 2, close parentheses, and that should give me -3. If it doesn't, I gotta make a new video. And there you go, -3. It checks out on the calculator. Okay, all right, so back to this. We have now transformed the parent function's coordinates. And you see from the parent function, I chose -pi/2 to 2 pi. If you want, I think you could get away with just 0 to 2 pi. So possibly, okay. All right, so now I'm gonna plot my points down below. So this graph is gonna be a little different. Where they intersect, oops, no, go back. Where my axes intersect, I'm not going to consider that 1, 0, 0, only because of the transformations that we're doing. So when I label this, I'm going to use the points above. Because honestly, in these transform points, do you see a 0 anywhere? And that's no. So when I go with these transform points, am I in the right target? Yep. We're going to say pi over 4. This is pi over 2. 3 pi over 4. Pi. 5 pi over 4. And 3 pi over 2. And the highest we go is 3. So 1, 2, 3. And then the lowest we go is -3. 1, 2, 3. That's perfect. Now let's go ahead and plot our points. At pi over 4, I'm at -3. At pi over 2, I am at 0. So we'll make that 0. At 3 pi over 4, we're at 3. And then pi, we're back at 0. And then 5 pi over 4, we're at -3. And then 3 pi over 2, we're at 0. Okay. Connect, and here's what we look like. This is our transformed sine function that we just did by transformations. We took the original sine function, we stretched it by 3, we compressed it by 1/2, and then we shifted it over to the right pi over 2 units. Fun stuff, huh? Okay. Let's do another transformation one, and then I will show you key points. Okay. And it always helps to just know how to rewrite these. So we just rewrite the inside of the function. So for 2 cosine 4x plus 3 pi, once again, what I'm going to do is factor out the 4 from both of these terms. Meaning we're going to get 2 cosine, bracket for neatness. I factor out the 4, and parentheses, you should get x plus 3 pi over 4. And that's good, that's good. And don't forget that there was a +1 out here. Okay. I'm actually going to go back to the first problem because I think I ignored some things, but you can definitely, you probably grasped them. It said amplitude, and then it says period and phase shift. So first off, the amplitude was 3. The period is always 2 pi over omega, the absolute value of omega. And here our omega was 2. So you'd get 2 pi over 2, or just pi. And then the phase shift we have listed above in the green. The phase shift was x minus pi over 2. Okay, cool. Forgot to label those things. All right, back to this one. Let's go ahead and look at the transformations going on. Again, oh, forget about that. The 2 is a vertical stretch by 2 units. The 4 is a horizontal compression by 1/4. The green is the horizontal shift right by, actually not right, left, because it's x plus, now it's going to be to the left. By 3 pi over 4 units. And then the 1 is a vertical shift up by 1 unit. The other one was minus, right? Yes. Okay. So that's plus. Okay. And for your viewing pleasure, I have the parent function coordinates of cosine on the left side, and I have the transformations that we're going to do written on the right side. So all we have to do is transform. So once again, the horizontal compression is 1/4. Since it's 4, you multiply by the reciprocal. And then since it's x plus 3 pi over 4, we're going to subtract 3 pi over 4. Okay. And then for the y values, you're going to multiply them by 2 and then add 1. So we'll get some calculator work ahead of us. But I'll just take care of the cosines for now, of the y values for now. You get 0, 2 times 0 plus 1 gives me 1. 2 times 1 plus 1 gives me 3. 0 plus 1 gives me 1. 2 times negative 1 is negative 2 plus 1, which gives me negative 1. And then 0, and then 1, and then 2 and 3. Okay, back to the calculator. Yeah, look at those lovely fractions, right? Okay, so let's start over. We're going to say 1/4 times the first x value of negative pi over 2 minus 3 pi over 4. Oh, just so awful. You get negative 7 pi over 8. All right, 0 should be easy. 1/4 times 0 is 0, and 0 minus 3 pi over 4 is negative 3 pi over 4. And then pi over 2 is next. So once again, just copy and paste, and then Oops. And then make that pi positive. 1/2 times pi over 2 minus 3 pi over 4, negative 5 pi over 8. And you'll probably notice some patterns that'll make your work easy. You might start guessing what the next value is, the next x value or transformation part. If you don't, then just keep using your calculator. And over here, it is now pi. So I'll just make that pi over 1. Hit enter, and then you get negative pi over 2. And then 3 pi over 2. Make that a 2. Make that a 3 pi. Hit enter. You get negative 3 pi over 8. And then last one for 2 pi. Make that a 1 down below. And make that a 2 pi. Hit enter. Negative pi over 4. And again, check our work. I have 2 cosine of 4 times, let's check the first one, sure, negative 7 pi over 8. So negative 7 pi over 8 minus 3 pi over, actually plus, sorry, plus 3 pi over 4, close, close, enter, and we get 0. What have I done? Forgot the 1 at the end. Don't forget the 1. There we go, plus 1. I was missing the 1 at the end of it, so I didn't do anything wrong. All right. So I could do the same. I could go up here, hit enter, and then at the end, hit that plus 1. And there we go, we get 1. Okay. Ooh, that was scary for a second. All right. Now we go ahead and plot. I'll start here. Negative 7 pi over 8. Negative 3 pi over 4. Negative 5 pi over 8. Negative pi over 2. Negative 3 pi over 8. And negative pi over 4. Highest we go is 3. 1, 2, 3. Lowest we go is negative 1. Which is right there. Okay. Let me make that prettier. Okay, and let's plot. Okay, so negative 7 pi over 8, we're at 1. Negative 3 pi over 4, we're at 3. Negative 5 pi over 8, back at 1. Negative pi over 2, we're at negative 1. Negative 3 pi over 8, we're at 1. And negative pi over 4, we're at 3. Okay. And here is our transform cosine function that we have vertically stretched by 2. We have horizontally compressed it by 1/4, and then shifted it left 3/4 units. And then after all that, we shifted up 1. Or you could even say, multiplied it, stretched it by 2, shifted it up 1, compressed it, shifted. Okay. And those are how transformation works. Oh, I need that one last part. What is our amp? Amp is 2, period is 2 pi over omega, which is 4. So pi over 2. And the phase shift is x plus 3 pi over 4. There you go. Okay, those are transformations. A lot faster. Well, for these ones, with all that crazy fraction work, a lot faster if you have a calculator, right? Okay. Now, if you absolutely hate transformations, then again, key points are here to the rescue. So it says the graph of y equals a sine of omega x minus phi plus b may also be written as, like I told you, you can factor out that omega. That's what we do here. We take this omega out and we end up with this newly manipulated trig function, where it's omega times x minus phi over omega, which is what we've done in the last 2 examples, just with less complicated looking symbols. Okay, where b is greater than 0 and c are real numbers, the graph will be a sine curve with an amplitude of the absolute value of a. As omega x minus phi varies from 0 to pi, 1 period will be traced out. So here's what we do for key points. So the phase shift will begin when you set the inside of the trig function, omega x minus phi equal to 0, and solve for x. And then the phase shift will end when you set the inside of the trig function, omega x minus phi equal to the revolutions of that trig function. So if it's sine, cosine, secant, or cosecant, you set it equal to 2 pi. If it's tangent or cotangent, you set it equal to pi. All right? So maybe I could sneak that in here. Let's see. Keep doing that. There you go. Okay, so you'll set the phase shift equal to pi if you're dealing with tangent or cotangent. Remember that. Okay, and then you'll solve it for x. All right. The number phi over omega is called the phase shift of the graph of sine or cosine. Okay, so let's go ahead and graph this by key points. We don't even need to rewrite it. We don't care about rewriting it because we're not using transformations. We're using key points. So the very first thing we're going to do is find amplitude, period, and phase shift. Okay, so easy enough. Amp is 2. Period is 2 pi over omega, which here it is 3. And then phase shift, so we need to have the beginning of the phase shift and the end of the phase shift to solve for. So I'll do that over here. I'll say begin phase shift is going to take the inside of this trig function, 3x plus pi over 2, and you set it equal to 0. Now go ahead and solve for x. We'll get 3x equals negative pi over 2. And then if you divide by 3, you'll get x equals negative pi over 6. This is where the phase shift begins. And now we need to find where it ends. So we're dealing with cosine, which means to find the ending, you'll take the phase shift and set it equal to 2 pi, because that's the period, that's the cycle of regular cosine. And that's all it says above. You'll set it equal to 2 pi. You'll set the phase shift equal to 2 pi if you're dealing with sine, cosine, cosecant, or secant. Okay. And then end phase shift. Three x plus pi over 2 equal to 2 pi. You'll get 3x equal to 2 pi minus pi over 2. It's easier to combine these into one fraction before dividing by 3. That means if you put that over 1, you'd get 2 over 2, 4 pi over 2 minus pi over 2, you'll get 3 pi over 2. And then if you divide by 3, you'll get pi over 2. And this is where our phase shift will end. Yeah, I love that tool. That's a cool tool. Okay, that's everything you need for step 1. Amplitude, period, phase shift. Where it begins, where it ends. Because now that's going to take us into the subintervals. Now you're going to take your interval, phi over omega, and phi over omega plus 2 pi over omega, which is what we just found. That interval is stating the beginning of the phase shift and the end of the phase shift. So let me write that above. Negative pi over 6 and pi over 2. So that's what we found. Beginning of the phase shifts at pi, negative pi over 6, end of the phase shifts at pi over 2. Now we must split this into 4 subintervals. So you must remember that one formula to find the length of the subintervals. And it's still take the period we found, 2 pi over 3, and divide it by 4. That was our period, right? 2 pi over 3 and divided by 4. Which means the length of each subinterval is going to be, you get 2 pi over 3, put that over 1, so you get times 1/4, and you'll get pi over 6. So this is the length of each subinterval. So now we get to making our intervals. All right. So interval 1. We start at negative pi over 6. We add a length of pi over 6. Negative pi over 6 plus pi over 6 gives us 0. Interval 2. We start at 0 and add a sublength of pi over 6, and you'll end at pi over 6. Hey, these are working out easy. Interval 3. We start at pi over 6. You add another pi over 6. That gives you 2 pi over 6, or pi over 3. And then subinterval 4. Okay, and then for the fourth subinterval, you start with pi over 3, and you add another pi over 2. So pi over 3 plus pi, not pi over 2, pi over 6. And then you get a common denominator of 6, which will give you 2 pi over 6 plus pi over 6, which gives you 3 pi over 6, which gives you pi over 2. Okay. And the way to know if you did these correct is that your very last x value of your subintervals matches the last value of your main subinterval. If those two match up, then you did it right. Okay. You now have your 5 key points, which means let's plug them all in. Let me pause. Okay, so now we take all our key points we just found and plug them into the function above. So with x equals negative pi over 6, x equals 0, x equals pi over 6, and that'd be y equals, and then x equals pi over 3, and x equals pi over 2. Y equals. And like I said, calculator makes your life a whole lot easier. So this time I'm going to use the table feature. I'm going to do 2 cosine 3x plus pi over 2, just like the original problem states, and then hit enter. And make sure you just highlight the word ask, hit enter. And now we're going to type in the exact x values you see on the paper to your right. So negative pi over 6 gives me 2. 0 gives me 0. Pi over 6 gives me negative 2. Then we move on to pi over 3. Pi over 3. Negative 4e to the negative 12th. So that's basically 0. And then pi over 2 gives me negative 2. Okay. Two, 0, negative 2. Did I type that last one in right? No, not negative 2. Pi over 2 gives me 2, not negative 2. I was like, that doesn't look right. Okay, and let's plot. And this one actually matches up. So I'll have negative pi over 6, 0, pi over 6, pi over 3, pi over 2. And we go up 2, down 2. And negative pi over 6, we are at 2, 0, -2, 0, 2. And here's what our trig function looks like with key points. Woo! All right. Okay. Last one. I'm going to do this one by transformation. I think it's just so much faster, right? So here it says graph this trig function, and of course, find amp, period, and phase shift. So first I'm going to rewrite it so we see the transformations that are going on. Y equals 2 tangent bracket, factor that 4 out, and you have x minus pi over 4. And then once again, label your transformations. You have a vertical stretch by 2. You've got a horizontal compression by 1/4. And you've got a horizontal shift right by pi over 4. Okay. So now all we need to know are the parent function coordinates for tangent. So let's just try to remember those, right? So there's x and tangent x. And we did negative pi to pi. So let's just do 0, pi over 4, pi over 2, 3 pi over 4, and pi. So I'm just doing 0 to pi for the parent function. So tangent at 0 is 0, 1, undefined, -1, and then 0. Actually, might need one more coordinate. Maybe if we did negative pi over 4. So let me see. I'll just put it down here for now. No, it's not going to look right. Okay, you know what? We'll just roll with these and see what happens. Okay. So let's go ahead and transform it. So we will transform. And for my x values, we're going to multiply them by 1/4 and add pi over 4. For my y values, this one's easy. We're just going to multiply by 2. So we can get those out the way already. 0, 2, undefined, -2, 0. And now for my x values, strictly calculator, unless you like doing all that fraction work by hand. I like doing it by hand, but I'm trying to save time on this video. And saving you time by showing you how to use the calculator to do the fractions. Okay, first one simple. If you plug in 0, you get 1/4 times 0, which is 0, and you'll get pi over 4. All right, next one is 1/4 times pi over 4 plus pi over 4. And we're going to get 5 pi over 16. And then next is for pi over 2, so just copy and paste. Make that a 2. You get 3 pi over 8. Next one is for 3 pi over 4. You get 7 pi over 16. And the last one is just for pi. Make that a 1. Get rid of that 3. And you're going to get pi over 2. Okay, fraction work is done. Now all we have to do is plot. Okay, I think I'm going to use the, no, I'll keep this the same. Okay, so when I write my numbers, I'll have pi over 4 here. I'll have 5 pi over 16 here. Three pi over 8. 7 pi over 16. And pi over 2. I have a vertical asymptote at 3 pi over 8. And then my points, pi over 4 and 0. Well, the highest I go is 2 and negative 2. You know what those are. 5 pi over 16 and 2. 7 pi over 16 and negative 2. 0, and if I wanted another point, it'd be at 2 there. Okay, and this would also be a vertical asymptote. So here's what we have. And there is the tangent function that has been transformed by a vertical stretch of 2, a horizontal compression of 1/4, and a shift to the right by pi over 4. Okay. Answering the other questions, your amp is 2. Your period is 2 pi over 4, or pi halves. And your phase shift was the x minus pi over 4. So let's just write better. Let me erase that, because that's ugly. There we go. Much better. And there you go. And again, if you want to see key points done on this exact one or any of the other ones, let me know. We can do it in class. But that ends chapter 7. Get you ready for your review. So once again, when it comes to graphing, choose one method. If you like transformations, stick with transformations. If you like key points, stick with key points. Do not try both. Only use one. And that's it. See you in chapter 8.